hi everyone. Really big responsibility to close the conference. I have seen you have been through quite a bunch of talks, so I will try to keep it short. I am the team lead of visitor profiling. It is basically a team that uses data science and machine learning to personalize our website and Booking.com web platforms. What I wanted to, all right. First slide is missing. So what I wanted to discuss is mainly one approach that we use to develop a machine learning product. And this is understood very flexibly. It might be just a feature. It might be an individual experiment. So it doesn't need to be a really big product. It might be a really small change, but it does have some kind of machine learning or artificial intelligence behind. And the key point to understand, and I think it was briefly touched on a previous talk, is growth. For Booking, growth is fundamental. And we see that AI is part of the strategy to keep growing the company. Particularly, we really like the analogy of a flywheel. So I don't know how many of you are familiar with the concept of flywheels, but it's something that you use in motors to keep the engine going even when it goes through ups and downs in power. What it helps us here is that we do see that there is a lot of network effects when you get machine learning right. Particularly, we think that if we have users, those users will give us some behavioral data that I think is still quite important for our domain. And that data will help us build even better models. And hopefully, if we get them right, it will help us improve the user experience and get more users in return. So this keeps growing on their own. So I will go through phase by phase of how to grow a machine learning product. And I will start with data collection. It is something that it's really easy to overlook, especially at big companies. Sometimes we take it for granted. But my advice there is start collecting data early and as often as possible, as many details as possible, because those small details are what you usually overlook. So just to give us, to give you an example of what we do at Booking, we try to keep a trace of what we call the customer journey. So when a user comes to our website, we try to analyze every single thing that they are doing in the website. Particularly, for example, we try to find out what do they search for, what destination, what kind of trip did they have in mind. Then we will go and see what properties did they look at. Did they like them? How much time did they engage? Which photos did they look at? What were they trying to book? Did they actually try to book but then maybe change their minds? So we try to log all this information and keep the data as raw as possible, because this data will later on feed into the machine learning models. So just to bring down to earth some search data that we log, particularly, for example, the number of adults that were searched, what was the check-in date. And this might seem basic, but for example, something that we also try to look at is which filters do usually people apply, because this is something that will also inform us what kind of characteristics of the properties are people trying to search for. Another interesting feature that it's quite dynamic is what is the total number of properties that we got for your search, because depending on several features in our logic, this might vary. And then trying to come back and figure out what did exactly an user get is quite a tricky task. But instead, if we collect that information when the user gets it, it's much better. And also quite interesting is we log all the properties that you get in a given search, and this will later on also help us understand better if the properties that we are offering you when you search are actually the properties that you were looking for. So just to give a couple of technical examples on how do we collect data, this is a relatively standard pipeline that we use. So we have our own proprietary event system that is basically some version of enterprise service bus. And in the end, one of the end points of this system will be going to Hadoop and basically dumping all the raw event data that we have into Hadoop. And then we have I will say at least hundreds of workflows that take care of processing this data and churning out the specific parts of information that we would like to analyze. So in this case, for example, if we are trying to analyze the search results page, we will process this data and try to flatten it out so that it's really easier to analyze instead of going directly to the raw events that might be terabytes of data. This is a more recent example of something that we are actively working on because we think that it might power our next generation of machine learning models, and it's basically using streams. So the problem with the previous pipeline is that it's relatively infrequent. So most of the analysis workflows that we use for machine learning models might run daily. Instead, the idea of streams is that we will theoretically be able to support almost real-time machine learning. And something that we use there is Kafka as a streaming technology. For example, for when you see a property, we will have a hotel impression Kafka topic, and then this will eventually be dumped into a Cassandra database where we could easily retrieve this data from. So once we have some data collection, let's say we already have the data that we need, and we are going to use it on a machine learning model. Something that we figure out that also requires a lot of time to think about is what are exactly the features that your machine learning model is going to use. So something that is particularly important when you're trying to deploy a model into production is to make sure that these features are as close as possible in production to what the data scientist or the person that was building the model actually use for training data, because depending on how close they are, this might change the results. So a solution that we have internally give us some understanding of which features are already available in production, are relatively easy to reuse. So for example, if I am searching for a given feature, I will see all the possible implementations that we already have, so that it will speed up the time to market of a model. Then something that we also consider is that a particular feature might have different versions depending on where exactly in your user journey you are. So for example, if we talk about the feature called book window, that is basically the difference in number of days between your today, the day that you're making the search, and when are you planning to stay at the property. Depending if it is before you do the booking, we will look at your search. But let's say you already made the booking, then we will look at your reservation. And the idea is that this will happen transparently when we are collecting the features to use for the models, and we will know which model is trying to use which feature in what context, pretty much automatically without having to manually trigger this. Also, a nice characteristic that we built into this model is basically trying to resolve features recursively. Because some features, for example, the booking window might rely on the check-in day, which in turn rely on parsing what is the search configuration that the user is looking at. So we try to do this recursively to try to come up with as many features as possible. Another mechanism that we have, and this ties in with the different data collection strategy that we are starting to use, is something that is called a feature store. That is basically a repository of data that we can easily reuse for prediction time as well. So what we have is that those Kafka streams that I previously touched on are ending in Cassandra, and from Cassandra we can also feed them relatively easily to the machine learning models. So this is another pipeline to also feed features into the models. Now, once we have some features, some model, and we reach out relatively stable configuration for the data, then what we really need to do is figure out how to do models or machine learning products that are actually useful for your customers. And then in that part, I really like a framework that we use internally that is kind of giving some magical powers to data scientists. So if you see, there are around 7 characteristics that are quite powerful and are let's say, specialties of a data scientist or a machine learning practitioner. And something that I will touch briefly on will be guessing facts about the present, which is quite critical in a website. We want to provide you information when you are making the decision, but also untangling complexity. Because what we have is we have a lot of data, but we want to present you that data in a way that it's easy for you to take a decision. We don't want to burden you with a lot of choices. We want to make it as simple as possible so that you trust that you are making the right decision. So pretty standard task that we use for machine learning is trying to predict where our users will go. This is a common problem, and in our domain, it basically boils down to, if we know that you have been making some searches, can we rely on similar users or people that did the same search to figure out where are you actually going to end up booking? Or if we know that you have been to some destinations, what is your next destination? How does it look like? We can say that the power that we are trying to use here is guessing a fact about the present, because we do have some information in the present about what is it that you have been doing. And one of the tasks that we can do here is recommend the destination. This is particularly the mobile product where we present possible destinations that you will be happy to go for. Something that is interesting to realize is that pretty much exactly the machine learning model can be used in different contexts. So later on, we faced a similar situation when we have our search box, and the user might not have given us any query yet. So the search box is empty. And what we used to do in these cases is that we will not provide any autocomplete suggestion, because we thought, okay, if you have not given us any query, how can we guess what you are going to query? It turns out that we can easily rely on this same task, because it's basically the same task. We don't know anything about your specific query, but we do know what you have been doing before. So even before you type anything, we will try to suggest you some popular destinations. And this depends, again, on what have you been browsing at, potentially what is your current location, and other features that we use. On a bit of a different topic, a quite interesting example that my team worked at was trying to summarize information that we have in our reviews. So I will say one of the strong points about Booking is that we have a lot of reviews about properties, and that is something that people really like. But it's also a curse, because a property might have thousands of reviews, and this is not something that you are going to read. So what we tried to do was, how can we summarize the important bits so that you can get a hold on what are the strengths of this property, and then you can take a decision of whether this is something that you are that you are willing to book, or you are looking for some other characteristics. So particularly what we did was we used unsupervised learning in this task, and what we did was trying to extract keywords from the reviews, and those keywords will give us clusters. And then once we identified the clusters, we will know what were the keywords for specific clusters, and then we start looking at them. And if we saw that a cluster were having a lot of works about location, we will figure out, okay, these reviews that have these keywords speak mostly about location, and we will try to categorize them about location. And then we can also have sentiment analysis and say how many reviews speak positively about this topic. And what we have here is that we have somewhere around 20 topics to have a good coverage. And then we can say how many reviews are talking about each topic, which one speak positively about this property, and we can present an overview without you having to read close to 1,000 reviews. Something that it also shows up frequently when you are implementing machine learning models in industry is that you want to reuse them, and you want to be able to use them across your product with a relatively easiness, because you don't want to be losing a lot of time in implementing the model each time. So a question that we faced frequently was, how can we deliver these models in a scalable and reusable way? And is also model discovery across the company. So once again, we develop an internal tool, and unfortunately, I'm not able to disclose as much information here, but the basic idea is that internally you will know which are the machine learning models that have been produced. Hopefully, you will also be able to know which products have been using them and what were the results of those features, whether they were actually positive for the business. And also you will have some model description and some description about the training itself, so that if you want to follow or iterate on that, you will also know how what's exactly the data looking like when the data scientist was training this model. Cool, so let's say we basically did all this part and we reach out a point when we have a model that we think will benefit the users. So how do you go about making sure that it's actually better for our users and it is not something that we think is better but it's actually going to be detrimental to the customer experience? So we use a fairly standard tool here that is A/B testing. A/B testing is heavily used in booking. At any given time, we might have thousands of experiments running, so it might be really small changes, but it might be also really bold ones. If you use our product, you will see more and more bigger changes coming. And I would like to do an exercise here. So I hope that you can have a rough idea of how these two options look like, but which of you prefer the option on your left? If you can raise your hand if you prefer the option on your left. All right. Which of you prefer the option on your right? All right. It seems that the tool worked quite well because that was precisely the option that most of our users picked. This is basically what we do. We present two versions of the product. So one version will go to 50% of our customers, another version will go to the other 50%, and we will compare what did they do, how much search did they generate, how much did they engage with the product, did they end up booking more, does it change any other kind of behavior? And we have a fairly advanced experimentation tool framework that help us track even to the point of how many customer service tickets is a change generating, because it's something that we are interested in looking at. Something that I also want to touch on, because it's not self-evident, is whether better accuracy should be an end on itself. So something that you will see quite frequently in machine learning is that the algorithms are measured on some kind of accuracy, and that's what they are optimizing. And sometimes what happens is that that is not the sole indicator of whether a change is going to be successful. So what happens quite frequently is that increasing the accuracy might not necessarily increase the reward of that task. So what I'm talking about is specifically accuracy understood as a loss function that is being optimized with your machine learning algorithm that might not be targeting directly the KPI. So in our case, at least for the core of our business, the KPI is how many bookings are being made, but it's relatively hard in most of our changes to directly optimize for it, and sometimes we will go for optimizing for an intermediate metric that our machine learning models can predict better. And what happens is that if the relationship is linear, so in the y-axis you have some kind of measure of KPIs that hopefully correlates with money, you will see that if the relation is linear, you will be really happy to keep increasing your accuracy, and it will theoretically keep you giving rewards, so keep you giving you more money or more engagement in your product. Instead, what we see is that most of the time this relationship is not linear. So sometimes it will happen that you need to keep investing on your product for a bit because the accuracy is not great. And then eventually it will take off and we will actually see that we can exploit this product for a while. Instead, something that might happen as well is that relatively low accuracy gives you good return, and up to a point that maybe is not great in accuracy, but it's giving you almost all the return. And now improving the accuracy will be only marginal. And a pretty common example of this is a basic algorithm that will take into account popularity among users, will most of the time give you, I would say, 70% of the way. And then that's your base to beat. And depending on how critical it is to actually personalize for your users, that relationship might change. So something that I wanted to share is it is important to know when to abandon a given approach. And by abandon, I don't mean completely destroy your product, but let's say stop investing on improving it. That it has reached a point when it's quite mature and more improvements might not more lead to more return. So something that happens is kind of a saturation effect. So you will not get more returns. But something that happens as well is that you will just change traffic within your product, but not really impact the end goal. So something that we can say is that in these cases, the KPI is not sensitive to the improvements in the accuracy that you are making in the machine learning model. And one case that I can share that happened within our team is that at some point, improving the recommendations that we have for destinations, at least on some parts of our products, was not actually leading to the end result of people booking more destinations. Mostly what was, it was leading to more users clicking these destinations because it was a better prediction, but maybe those users were not actually interested in booking, but more in exploring that destination and will later on make up the decision. And the thing is that something that happens with A/B testing is that it's rather biased for short-term changes, and then it's hard to pick up whether these specific cases, was it that the product was not actually better, or was it that the timeline for getting a better product was much more delayed? I would also like to share at least one case when I see that it makes sense to invest, so basically pass through a valley of not having a great return, but keep improving in the accuracy in the hope that it will eventually bring a high reward, so it will eventually hit the KPI. And something that it's really useful to understand is that it does require a leap of faith. So it's mostly a business decision. Someone might need to trust that this is a good direction, but it's usually accompanied with some kind of potential reward that must be high depending on the investment that you are making. And another case that happens frequently is that you will go along the industry and say that deep learning is something that we see that other companies are doing, and then we will say, hey, how can we apply this technology on our domain? How can it make our business better? So even if initially we don't see many returns, we will eventually see that it is actually improving the business. So what would you say that is in this image? It's a relatively hard image to understand. What happens with some of our images in the properties is that most of the images comes from the property owners themselves. So if it is a professionally managed hotel, they will have great pictures. But if it is a relatively small business owner or it is an apartment, sometimes the pictures tend not to be that great, especially in terms of composition. So what you see there is kind of a terrace looking towards the sea or some kind of body of water, but it's not really visible what is it in there. We try to compare if we were going for a commercial solution, and I don't have the specific link for this, but I'm pretty sure it's available online. You can upload any picture, and it will give you back a generic label. And what we see here is that it's easily confused because it thinks it's a crib, maybe because of the rails. It's also saying that there is some furniture, which is a fair guess, but it doesn't seem to be very useful for our domain. If we present this kind of information to the user, might not be actually what we want. Instead, what we did was actually training some deep learning neural networks on the labels that we already had from property owners or from our own human tagging. And what we have here is that we are able to predict that this corresponds to a sea view, that there is a balcony, that there is some kind of patio here, and there's also a sitting area. So again, this part is, the technology is quite generic, and we did not come up with deep learning, but the application to our specific domain does require some investment on researching how does it tie into our business. However, I will say that overall the reality is really way messier, and the way these investment to the accuracy to reward curves looks is usually something like, should we invest when it's not that profitable, so in the hope that will eventually pick up? When you are at this point of the investment, you usually don't know upfront whether it's going to pick up in the future. So my advice will be keep investing in something that you truly believe might bring the results. And that's what I had to share.